Hello, through this lesson, we will talk about the statistics and probability, mainly on inferential statistics. This is a second topic from the statistics, which it's after you have already understood the descriptive statistics, because descriptive statistics is basically from an amount of data that you have or a certain population, you want to understand the certain characteristics that those data have. Now that you already understood those characteristics, you can be doing a model through inferential statistics to determine the probability towards getting this amount of data and or to getting a specific outcome that you may be thinking. The inferential statistics is the basic beginning to understand machine learning, and through here we will start for sampling. Sampling basically it will be from all this population that we were talking about at the descriptive statistics. Let's say, for example, that we have a ball, and in this ball we are going to be having certain amount of marbles, for example, 3 red marbles and 2 green marbles. And from this whole population, we will be taking only 2 marbles. So that will be our sample. And now from what are going to be the different models that we can get? Well, let's go and see that. Now, the first thing for sampling, it will be to understand what are the combinatory. Let's say that we want to understand from the way that we're going to be getting out the marbles, what are the whole amount of combinations of possible combinations that we can get from the 2 marbles that we're going to be getting. If we take the two marbles out of the box at the same time, that will be the combinatory. However, in case that the order that you're taking out the marbles, so for example, it will depend if you take first a green marble and then a red marble, rather than you can create a second option for getting a red marble and then a green marble. Instead of taking both marbles at the same time and you only get one of each different color, that would be the case of a permutation. You see two difference between these. The combinatory, it's for when the you want to understand the whole possibilities, while permutation is just to describe when the whole possibilities depend on a specific order. The second thing for understanding sampling, it will be the size of the population that we're going to be getting. Now, let's say that in this case, we have a specific amount of marbles, right? So from that population that we have already get, we want to understand what would be a good sample to get towards this sample can describe all the probability of getting of getting one of different colors. So in the whole population, we know that there's that there will be um 2/3, sorry, 2/5 of getting a green marble, right? This is the probability of the whole population of getting a green marble. However, if we only take 2 marbles as our sample, what will be that probability? Well, that will depend. That will be dynamically based on the sample that we have get. So we should be doing a lot of different tests towards understanding these probabilities. These probabilities of sample, which are represented as p hat, have a shape, meaning that they are based on the central limit theorem that represents that the middle of the frequency of probabilities from the sample are going to be on um, the whole population. This would be the mean of them are going to be over the mean of all of the population probability. The central limit theorem, what tells us then is that the amount of the means, the mean of the means would be the mean itself of the whole population. All right, now the standard error is basically characteristic of these probabilities from the sample. Let's say that we want that that there's to have more information about the behavior of these sampling probabilities, and we want them to be around the 68% of our population, so of our whole population, so that let's say that the 68% of the of all the p hats would be around the the standard error, which would be the probability of all the population plus less than one standard deviation of our whole population. That is what the standard error gives us. Now, what the confidence intervals represent is for us to modify not only to have the 68% of the probability sample, but of the whole, but you can modify this percentage, meaning that um, that you could be having, for example, the 98% of all the probability samples, or even less, or bigger. Why do we will be doing this, you could be asking? And that is a really good question. Well, basically, is that let's say that we want to have a probability really near our center. So, for example, that our probability it's around here. It's really close to our probability. We don't want them to have a lot of uncertainty, and this could be actually really useful uh, for example, uh, for the production of certain materials such as medical material or spatial material. Otherwise, if we want this interval to be really high, it will be more for production of other type of things that they don't require that significant um, closeness to the or that amount of precision towards the data. So that interval, that will be the confidence interval, right? Um, this confidence interval will actually be depending based on the amount of population that we have. So in case that and why that depends on our population, well, that is basically based on what is the standard deviation. So we know that the standard deviation, it will be equal and in this case, the standard deviation of the probability hat of our samples, it will be equal to the whole probability, in this case 2 divided by 5, plus 1 minus that probability divided by the total amount of population that we have. And this, the square root of this, because if not, that will be the variance. Okay, as you can see, the standard deviation is it will be when you increase the amount of population, the standard deviation will decrease, meaning that as much population that we have, our sampling, it's much closer and it's much more accurate. And if we have less amount of population, that will make our confidence intervals go further away. This is an inversive relation between both of those variables. Now, the confidence interval, what this means is that so basically, once we have understood that there's a relationship between the probability and these intervals, then of the population and these intervals, we could determine that based on a certain amount of population, for example, after 30 users, we will be using t-score towards doing the amount of sigmas for changing these intervals. So the score here would be representing a coefficient that is multiplied by the sigma value or the standard deviation, so that the interval could be amplified or be shortened. This score value is based on a table that is representing the amount of these of the standard deviations that you're having. Say that next, the t-score will be when you are going to be having less than 30 as the population, you are going to be using t-score. Otherwise, you are going to be using z-score. That is for this lesson, and we will continue moreover on hypothesis testing for next lesson.